Right, so your homework that most of you have done. Alright. So we had to plot the graph of this function, 3x plus 2. So we've got some inputs. You could choose which inputs you wanted to use. The outputs come from putting these inputs into this function. So for instance, 0, well we do 3 times 0 is 0, plus 2 makes 2. 3 times 1 plus 2 is 3 times 2 is plus 2 is 3 times 3 is plus 2 11. Right, so now remember last time these ordered pairs can be turned into coordinates, the x and the y coordinate, and those that have done coordinates before, you'll remember that the x one comes first, and now it makes sense why, because it's the input gives the output. And then the coordinates for this one are 1, 5, this one it's 2, 8, and this one is 3, 11. Now we plot those ordered points together on here, so 0 on the inputs, so the x is all the inputs, so the 0 matches 2 for 2. So I put a.
You missed the 1, by the way.
I didn't miss it, look, I've done 2, 4, 6,
oh,
8. If you're right, if I'd have done 2, 3, 4, it would have been wrong. One of you, in doing your homework just now, started that at 10. Now, technically, there might not be a problem with that, because you can start your graph, your axes at whatever you like, but we need to show all of them, right, in this case. So we've got 0, 2, 1 matches to 5, so about there. 2 matches to 8. 3 matches to 11. Now, we then join all these points with a line. Now remember we said it doesn't stop, so we're going to keep the line going, and I can keep it going up as well. Is that straight?
Mm-hmm.
Yeah. Is that straight?
Yeah.
Right, so the line keeps going, and some of you very nicely put your arrow at either end to show it does go on forever. Alright, so there's your graph, and we should also write the function next to the line so we know what we're doing. Right, so that was your homework. So most of you, your homework looked like that, didn't it? Now, just a little question. Do you have any comment to make on the choice of axis that I did? How I chose to write the numbers on the axis? Jamie already commented why. Can you give me a reason, or maybe an improvement that you think, and why? Sophie?
Right, so you want us to give you an improvement?
Yeah. What's slightly difficult about what I chose to do with my axis, Sophie?
Well, that it's because you did it in 2, which is not so hard, but for example, you said 2, 4, 6,
yeah,
and in the middle of 2 and 4 is 3, and maybe it's hard for us to find exactly the middle, so like you can't be that accurate.
Exactly, yeah. There's no line, so I've had to have a bit of a guess where, so for instance, 5 would be. So what would have been better would to have been do it up in 1s in this case.
Well, so you did the x-axis on 1, 2, 3, 4, 5, and then the y did 2, 4, 6.
Does that matter?
No.
Yeah.
Because you need a larger y-axis than the x-axis to be able to plot the points.
Good point. The y's go up quicker. That's why I did it, because I've not got much space, and I needed to get from 0 all the way up to 11 quite quickly.
Basically, the x-axis is the amount of points you're plotting down.
Yeah. So the x one nice and easy, but I need to go up. I needed to get to 11 or 12 quite quickly. So that's why I chose to do 2, 4, 6, 8, 10. But as you've said, with the paper that I'm using, it might be not as accurate to do it in that way.
But at the y-axis you stopped at 5. Aren't you supposed to stop at 11?
This is the x-axis.
Yeah, but you stopped at 5, but the highest number in the x-axis there is 11.
No, the highest number on the x-axis is actually 3.
Oh, that's X.
Yeah,
Oh, yeah.
that's the x. This is the y. Why did I go up to 5?
Because I.
Well, the highest was 3, but do I stop at 3?
No.
No, so my axis can go up to 5. If I've only plotted 4 points there, would I go up to 28 on the x-axis? for
No.
instance?
No, but you can.
You could, but I wouldn't bother. Yeah. So I've got a nice graph. It
You
fits
could
on my
either stop-
page.
You
There
can-
is some improvement. Now maybe I would only plot the ones that I know exactly fall, and the other 2 would fall on the line. Okay, but that's just a little point I have to make it look better. Okay. Anyway, so on the whole, pretty good. Now what we're trying to notice for this lesson though is trying to notice whether there is any quick way of being able to draw this graph without necessarily having to do all these points. So what I'm asking you for, I think Nico said something last lesson along this line, is if you look at this function, okay, so we're looking at this function, we could maybe look at the numbers in this function. Can you spot any link between those numbers and what happens in the graph? Now, I'm going to give you a couple of minutes to think and see what you can come up with, so we don't have to give an immediate answer. We're recording again.
What was the function of the other one, the other page? Like the
function on the other page was 2x
Did we make
minus
the table?
3, Sophie. What about that one? So, if we go back to this, okay, your ideas. So we're looking at these two numbers, the 3 and the 2, and we're trying to see whether those numbers help us. Now you have spotted something, that to go from 5 is this point, then to go to 8, then to go to 11, okay, that's going up each time by a value of
3.
3. Okay, so let me put that in. So maybe if I go do this, I'll draw a little line like that. So from where we were, and what about 5 to 2? Yeah. So this is always add 3 on each time, yeah? You notice that?
I don't get.
Well,
Yeah, I know.
on the output, we were at 2. So that's, if I have this line as well. So when we're at 2, to get to the next one, 5, we have to add 3. To get to the next one at 8, so we have to add 3. To get to the next one at 11, oh, my line's not very good there, halfway, we have to add 3. What do you think the next point will be? What do you predict?
3. Add
So we add
3.
3
15.
to 11 and we will get
14.
14. And is that 14?
Yeah.
Well, let's just check as well. The input for that point is what?
13.
4
4. So 4
times 3.
times 3 is
12.
12, plus 2 is
14.
14. So it looks like the plus 3, so this 3 here, what do we think? Maybe that's what it goes up by each time. As you go up one on the input, as you go up a new input level, the output is plus 3 bigger than the last one.
And with the other one, it works the same thing.
So does it work on the other one? Let's
Yeah.
have a look. So on this graph, it looks a bit messier.
2.
So we've got 2. Now, if we have a 2x there, what do you think it should go up by then?
2.
2.
So it should go up by 2.
So you always have to take the first number in the equation.
Okay, so look, we're at 0 is minus 3. So when we go across to 1, what should we go up by? 2. And does it?
Yeah.
Go across to the next input, we go up by
2.
2. Okay, so it goes up 2. Oh, I'm not doing this very well now, am I? Goes up by 2. Go across to the next input, it goes up by 2 to 3. From 3 it goes up to
5.
to 5. So it goes up by. So this one agrees, look. So this line, if it's 2x, it goes up by 2 every time. Alright? So that agrees with your idea here that the 3 is the plus 3.
We'll try another one, take another one.
Yeah,
Or if it's not
good
by
idea.
coincidence.
Good idea. It might be a coincidence. That's in maths we have to test, don't we? What about the plus 2 though? Any idea where we could get a clue for the plus 2?
In this one you can.
Is there any 2? Millie?
When you go down plus 3, and then you go along 2, then
We go across 1 actually. What about this?
The first one is 2.
First one. When it's 0, when the input is 0, the output is
Always the
2.
it's always
What about the other one? Let's check. What do you think 0 is going to be?
3.
3?
Well, the first one can be 0.
I think 0 is going to match with 3.
Minus
Yeah.
3.
Minus 3 might be. Ah, there you go. 0 matches to minus 3 there. Okay.
Check that it works for all.
Well, I'll tell you what. Let's have a look. So, if we do, what should we do? Y
5x.
equals 5x, okay.
Do we have to draw?
Let's do minus
minus
1.
Okay.
Okay, tell you what, we've got some tips. So we think
First
5 minus 1. Now before we get into doing it quickly, let's do our mapping diagram for one final time. 0, 1, 2, 3. Work out the outputs and let's see whether what we've come up with works.
minus 1.
Hang on. Right, let's have a look at the numbers that match to these inputs. So 0 matches to
Minus
So-
1.
5 times 0,
Negative
nothing,
1.
minus 1, so we've got negative 1.
4.
1 matches to
4.
5 times 1 is 5, minus 1 is 4.
9,
5 times 2 is 10, minus
14,
9.
14.
Okay,
19.
so if we
34.
plot those points then,
Should be
0
0.
matches to minus 1. 1 matches to 4. 2 matches to 9. I can't go any further, but that will do for the time being. Okay.
So, do we have to draw that now, quickly?
Right. Well, we will do, but just if you bear with me for a minute, just to show you. Right. So we've got a couple of things. Look, the minus 1 is where it starts. That is the minus 1. That's what Jaden came up with. Okay. And then if we go from 0 input across to the next input of 1 and we go up,
5.
we have to add
5.
5 to get to the 4. And again with the next one, go to the next input of 2, we have to go from 2, from 4, we go up to 9, so we have plus 5 again. So from there to there is plus 5. So it does look like that number matches to that one, and the minus 1 matches to where we start from. Now hopefully that will then help us.
But does it still work if the input is different numbers to 1, 2, 3, 4, 5, or is like
It should be.
Should
It should just keep going up, shouldn't it? It should keep going up.
if my first input
The
was
trouble
10,
is, this one, this number here, has to always match to what input?
minus 1.
No, the input is x equals what?
Minus 1.
No, that's the output.
X equals
This is the pair.
X.
The input is
X equals 0.
0. So we have, if we don't use 0 as the input, we can't use that as the output. So that number only matches to minus 1. When x is 0, sorry. That number matches. So anything. Okay? Make sense? Makes sense? So what we're going to do next lesson, we're going to use these skills to figure out whether we can draw a graph without needing to do this bit. So without needing to do this table of values, can we do it straight away? Now you might already be going, yeah, that's fine, which is good. Once we've done that, we'll be looking at can we, if I give you a graph, can you tell me what the function is, which is more important. Okay, more important. All right.